All right, so we are, it's the 22nd already? Wow, this month is flying past. All right, so our goal for today is to create flowcharts to make a proof. So we're going to say prove using flowcharts. Flowcharts. I'm going to tell you that when I went to high school, everybody complained about geometry class because of proofs. Okay, and it was pretty brutal, I'll be honest. Back when I went to school, they introduced proofs back in chapter 2, and we didn't do flowchart proofs. We did this thing called 2-column proofs, which we will get to later in the year. Our book introduces these things called flowchart proofs, which are a lot easier to wrap your head around. In fact, when we eventually do get to 2-column proofs, the way we're going to build 2-column proofs is first we're going to make a flowchart proof, and then we'll just convert that over into a 2-column proof. Okay, so, but this is one of the big key ideas of geometry, is this idea of, I've got something that I think is true, and I got some evidence to back it up. How can I connect all of that stuff to make a case that that statement is indeed true? Okay, the thing that sometimes annoys my students about proofs is this, okay? It is all about the steps. 100% it's about the steps. Okay, we already know we're not finding an answer to anything. The answer is given to us at the beginning of the problem. Our job is to show how we can connect the stuff that we know to arrive at that answer. So it's all communication. Okay, and because of that, there's sort of some certain ways that we do things. So it's going to be really important today. What we're going to try and do today is just get you used to what these things look like and what the rules for constructing them are. You're going to be doing this not just in chapter 3, but in chapters 5 and 6 and 8 later on this year. So this will be an important one for us today. And you guys are going to do awesome because you always do. So, all right. Let's get into this. Before we get started, don't worry about these flowcharts down here for right now. Before we get started, could you guys look at that first problem and tell me, do you think that those two triangles are similar? Yes or no, and why do you think they're similar? This says use full sentences. I'm totally okay if you guys use one of our shortcuts from Wednesday instead. I'm not even going to ask you to write a similarity statement just yet because we're about to do that in a second anyways. But are they similar? What do you think? Show me a thumbs up or a thumbs down. Similar, yes or no? That's a bunch of thumbs up. What's our reason for them being similar? Angle, angle. I got one pair of matching angles here. I got a second pair of matching angles here. That is absolutely angle, angle. So we're going to say yes by AA. AA what? AA similarity. Don't forget your squiggle. If you said AA, I would have, on a test, I would have to take a point off. Because this is not the only AA we're going to learn this year. There's angle-angle similarity, and there's also angle-angle congruence. So, well, for angle-angle congruence, we'll learn about it later, but it's going to look like this instead. So I need to know that you know that it's this and not this. This does similarity, this does congruence. We'll have a whole chapter on congruence later on. Thanks for asking that question, though. I appreciate that. All right, we got a flow chart here. This is the structure of how a flow chart is going to work. Except we're going to be adding some extra stuff into it. For right now, though, let's just focus on the actual structure. So the way this works is the conclusion that we're trying to draw is going to be down here on the bottom. Any evidence to support it is going to be in bubbles usually above, and then the arrows flow from the evidence to the conclusions. Now, eventually, each of these bubbles is going to have a reason for it. Right now, we're just going to focus on our conclusion bubble's reason. Okay? So our reason for this, how do we know? Because of angle-angle similarity. So if I were in a court of law and I was tasked with proving that these two triangles were similar, here's what I'd do. I would say, could you please notice that P and B have the same measure? That's what this bubble is saying. I would say also, please notice that angle A and angle T have the same measure. And since I've got two pairs of angles that have the same measure, by angle-angle similarity, then the triangles must be similar as well. And that's it. Okay, so let's look at one where we have not angle-angle. This one's not angle-angle, but it's which one? What's the other one that we learned on Wednesday? SAS, the sassy ones, right? And if we were going to check this really quickly, let's do it Mrs. Galligan style. You guys saw that in our work. I'm going to just write a proportion. Let's see, we got 2 and 8 go together, 3 and 12 go together. If I cross multiply that, am I going to get the same number on both sides? What's 8 times 3? 24. What's 2 times 12? Hey, that's good. So those are in proportion, which means I've got my two pairs of sides, and we have an angle. And is that angle sandwiched in between the two pair of sides? Yes. Can you put the laptop away for right now? Thank you. So we are congruent. Now, if I wanted to create a formal proof, in order to use side angle side, guys, I need you to put the book away and pay attention, please. Thank you. Okay. We've talked about this before. Okay. Thank you. If I'm going to use side angle side as my final reason here, you guys can go ahead and write that down. That is a key part of this. I'm going to need 3 pieces of evidence, one for each of these letters. So that's why I've got 3 bubbles across the top here. This first bubble is relating the 12 and the 13, so this is one of my S's. Now, we don't usually write this in. I'm just doing this sort of as a checklist. I've got another ratio of sides here, the 8 and the 2. And in order to make this work, I also need a pair of angles. I've started this statement for you. Can you please complete it? The measure of angle C is equal to, make sure you're putting a little m in front, measure of angle, and we knew that because of the tick marks. So there's my A. I got 2 sides, I got an angle, everything lines up so that the sides are around the angle sandwiched in between. Now, they're going to want us to do one other thing. We need to show that these two things are in proportion, which means we need to have an equation, and we're going to need to actually name the sides here. So if you look at this 12 here, and you look, can you find 12 in the picture? 12 is between what 2 letters? R and T. Do you see how they just took that 12 and changed it into a TR? Because TR is the thing that was 12. What was the 3? What are my 2 letters for the 3? DC, which was right here. So they're just changing these into letters. Can you guys do the same thing for the 8 and the 2 over here? Find the side that's got the 8 and give me the 2 letters. It doesn't matter what order we put them in. Find the side with the 8, give me those 2 letters. I'm seeing Q and R. No idea. And then they've got a 2 on the bottom here. The question was, are we on a regular schedule? I don't know. We haven't heard yet. If you'll as soon as we finish this example, I'll check my email and see. This 2 was between the C and the F. Did I make a mistake there? Oh, okay, we're all good. All right, and then we can complete our similarity statement. Now they gave us CFD, so they've chosen the order for the first triangle. We need to match them up. C is easy to match up because it's got an angle that's marked, so C goes with R. And then F and D. F is kind of on the shorter side from C, so I'm thinking Q. D is along the longer side from C, so I'm thinking T. All right, any questions? I'm just going to walk you through a couple more, and then we'll be done. We've got these two. Let me ask you guys to do this while I'm checking the email about the schedule. Could I just get you to, right above these, first of all, decide if they're congruent or not, and what would your, not congruent, decide if they're similar or not, and tell me which of your 2 reasons you would use for each of those. And then we'll build a flow chart based off of that in just a second. Some of you have already started working on your flow chart, and that's great. This will be an opportunity for you to check and make sure that your flow chart is correct, okay? This is going to seem a little bit strange to you. But when I'm building these things, I will typically start at the bottom and work my way up. I'll start at the end of my flow chart and work my way backwards. Yeah. I know that, well, you guys tell me, did you find that these 2 triangles were similar? Yes, I agree. And your reason was? Angle, angle. So we know they're going to be similar, so let's go ahead and start. We know the last step is going to be that these 2 things are similar. I'm going to say triangle CAF is similar to triangle, and I'll let you guys fill in the other 3 letters there. CAT, I misread that. Thank you very much. Cat. Is it pig? Cat and pig? Ah, they tried to trick us. They always do that. And we know what our reason is going to be. Hey, guys, let me get your attention, please. Don't miss this. What's our reason going to be? Angle, angle. So that's going to go right here. Our reasons always go kind of outside the bubble in the corner like that. And for right now, I only need you to give reasons on your final step. We're going to change that later on. Now, in order to use angle, angle, I'm going to need how many pieces of evidence? 2. I'm going to need 2 pieces of evidence. 1 for this pair of angles and 1 for this pair of angles. So I know that I'm going to have 2 bubbles that are feeding into this. My job now is to go out and find myself that evidence. Were there any angles that were easy for us to spot? This 56 and this 56.5 and this 56.5 were super easy for us to spot. So I'm going to go ahead and mark those 2. That's angle C and angle P. So the measure of angle C is equal to the measure of angle P. We were able to see that easily. I'm going to need 1 more pair of angles, though. Can you guys give me another pair of angles that would have to be equal? T and I. Now, I can see that I is 23.3. You must have done some calculations to figure out what T was, did you? And it ended up being 22.3 also? All right, so let's write it down. The measure of angle T equals the measure of angle I. But we're not done. We could have used the other one, yes. So if you use the other one, that's fine. But you're also going to need 1 more step. We're not done. I need you, because now C and P, we could see that those were equal. T and I, in the original picture, it didn't show the same number there. We had to do some work. So I need to give some evidence for this statement. I need a piece of evidence that shows how I knew that angle T and angle I were the same. What you did to find that You guys told me you did some work to come up with 22.3. Just show me how you did it. We're going to say the measure of angle T equals, how did you come up with that 22.3? I can't remember who told me what it was, but how would I find it? Yeah, 180. I should have made my bubble a little bit longer here. 180 minus 101.2 minus 56.5, and then equals 22.3. So I've got it, since that information, that 22.3 was not in the original picture, I've got to find evidence to show that those two things are equal. And now my proof's complete. What do you guys think? Not too bad? Let's try another one. One more. You guys are doing awesome. What do we got? LRN, ACB. So I'm going to assume that these two things are similar. The instructions kind of hint at that. Is this a side angle side one? Is this a side angle side one? We don't have angle for sure, but did it work out with side angle side? Yeah. So if we're doing side angle side, we must be using which sides over here? The ones that are on both sides of the angle, right? Those two and these two. Now, when we have a side angle side proof, it's going to be structured just like this one up here. So can you use this as a model to complete this one down here? So I'm just going to build out the bubbles that I know are going to be in this order. I'm going to need a bubble here that's going to have some fractions in it. I'm going to need a couple supporting bubbles up here. Oops, I'm writing down numbers from the other problem. And then I'm going to need a couple angles over here. I'm just copying down the format of the one that's right up above. Did you guys get these finished? Yeah. Okay. Gotcha. And did you have this step in there too? Yeah. Cool. Okay. Oh, we did it the other way. We did side angle side. This you can't. Okay. Yeah, I guess you could do side angle side for that. Yeah. The trouble is, side angle side for this, you would have had to find. You could not use the 56.5 for this if you're doing side angle side, because we don't have the two sides on both sides of that angle. Side angle side requires, if you're going to have if you've got a triangle and you're going to use side angle side, the angle has to be touching both of the sides with numbers in it. We don't have this right here. We could do side angle side with the 101.2. Then we need a bubble over here to show how this was also 101.2. So it's possible, but it's not going to look exactly like this. It would have another step in it. It would be a super easy fix though. Just change it so that you're using the 101.2, and then you would need one more bubble up here stating how angle G was also 101.2. This is why I get a little nervous about people working ahead and thinking like, oh, I already have this done on a test that would have at best maybe half credit on a problem like that. Okay, but I'm glad we talked about it. All right, I'm going to start building mine out here. Yours may look different, and that's fine. I chose to put my bigger side on the top. I'm going to use my calculator and get a decimal here. This comes out to about 2.3. And then what were my other two? 1025.5 and 290. Oops, that's not right. 1025 matches up with 439. Now, if you flip those fractions around and you had, instead of 2.3, you had 0.42, that's fine. But you've got to have the same number in each one, and you should be matching up corresponding sides when you're building those ratios. I'm hoping this also comes out to 2.3. Yay, it does. 2.3 repeating for both of those, so that's good. Now I just need to name the side that each of those came from. 295.4, that was here, that was AC. 126 was here, that was LR. Again, you might have these in a different order. That would be fine as long as everything matches up. That's AB. And the 439 is LN. And then my two angles were L and A. And that should wrap it up. Does anybody have any questions? Did anybody have something different there that you'd like me to check and see if it's also correct? One of the things about these proofs is there's like hundreds of different ways to do the same proof. All right. I will warn you that these proofs they might feel, for some of you, it may feel like I don't have a firm grasp of what's going on right now. And that's okay. This is our first day doing this. We're going to keep practicing over and over. As long as you're asking good questions, and then if you're not sure if something's right, please get my attention and give me a chance to check it over and give you feedback. We talked about a different way that we could have done this using side angle side instead, but it would have required some extra work. Okay, what I don't want you guys to do is come on to the test in 4 weeks thinking that you're doing your proofs correctly, and then finding out after I grade the test that you're making mistakes in the proof. Okay, so when we do have time, obviously we don't today, but when we do have time, please get my attention and allow me to look over your proofs and make sure that everything's working. Okay? Yes. I don't know. We're gonna go when the bell rings. First of all, okay. So if the bell doesn't ring at 10:55, then we don't leave. If the bell doesn't ring at 10:55, then we don't leave. Not right at the moment.